For organisations to be successful in whatever their endeavours, they need to be actively involved in thinking both operationally and strategically. Operational thinking allows them to continue day-to-day or business as usual operations in a smooth, efficient and effective manner. Operational thinking does not necessarily allow organisations to consider the longer-term direction that their organisation should take in conducting their business. Nor does it allow organisations to maintain an awareness of longer-term opportunities and threats. For this view, organisations must think strategically. In some cases, organisations will uncover gaps in their current capability that will impact on their ability to move in the desired strategic direction. These capability gaps may be critically important to the organisation. Some capability gaps will prevent an organisation from achieving strategic objectives that have been established, with resultant long-term consequences. The gap may result in opportunities that the organisation is unable to exploit, or the gaps may open vulnerabilities to threats from competitors or adversaries. Capability gaps come in an endless variety of shapes and sizes. If I consider my own life, I've got plenty of capability gaps. For example, I'd love to be able to surf at the beaches near my home, but I'm not able to do this currently. I don't own a surfboard. I don't have roof racks on my car, and I don't have the necessary skills to stand up on a surfboard. So I clearly have a serious capability gap. On a more serious note, I know of commercial organisations who've identified niches in their markets, but they lack the ability to be able to exploit those niches. Their capability gap might be in the form of a lack of people, a lack of process, or a lack of tools that they need to perform product development in order to address those niches with marketable solutions. On larger scales, some governments around the country would like to plug gaps in government-provided services such as health services for disadvantaged people or transportation services for particular regional areas. Some military organisations around the world may want to be able to monitor their national borders, but currently lack the capability to do this to a desired level. Once business stakeholders become aware of critical capability gaps and commit to either closing or reducing those gaps, they are establishing the need for a solution. Naturally, organisations will probably not be able to address all of the gaps in their capability, so they'll need to prioritise the gaps and concentrate on addressing the most critical gaps first. Establishment of a need for a solution marks the start of the systems engineering lifecycle and indeed the start of what we call the conceptual design phase of that lifecycle. We typically address these capability gaps in a methodical manner. We start by concentrating on the business or organisational needs and what the resultant requirements for the eventual solution might be. Business needs and requirements are, after all, what we are trying to address, so understanding these is a logical starting point. We then have a look at what the relevant stakeholders within the business would like to achieve. These stakeholders will be people who are involved with the business or the organisation in areas where the need exists. They will have particular views on what's required by the eventual solution. The stakeholders I'm talking about here are people who have a right to influence the requirements of our system. This simple definition might help you when you're trying to identify the stakeholders. We then move on to what some people consider to be the start of traditional systems engineering, where we take the business and stakeholder needs and develop a formal understanding of the system-level requirements that our potential solution must meet if it is to satisfy the stakeholder and business needs. An understanding of the system-level requirements allows us to take a detailed look at the potential system-level solutions that might exist. We'll be interested in knowing what the level of compliance these solutions will exhibit, what options the solutions will come with, how much they will cost and how long they will take to realise. We will also be interested in the risks associated with each solution and the longer-term issues such as sustainment and disposal. This will allow us to select a preferred system-level solution. This is a process that's sometimes referred to as system-level synthesis to give the feeling of evolving design. The term synthesis has its roots in Latin and before that Greek, meaning to place together. The need to stop our work periodically and check that we're in the right place is almost so obvious that it goes without mention, but in this MOOC, we'll mention it anyway. Once we've done all this work with our business stakeholders and we think we're ready to move on to solving their business needs, we will draw some breath and have a bit of a look at what we've achieved. This gives everyone a chance to review the work, look at the problem space that we've defined, look at the preferred system level solution we've selected, and confirm that we are ready to move on to the next stage. We call this review a system design review because that's what it is, a review of the system level requirements and the system level solution to ensure that the two are appropriately understood and appropriately matched before proceeding. Let's take a look at each of these 5 steps in order to gain a better appreciation of what's going on. Let's assume that the business stakeholders have selected a capability gap for reduction or closure. There's plenty of work for them to do in order to start addressing this gap. Let's look quickly at what needs to be done in order to define the business needs and requirements, and we'll then have a look at each of these areas in more detail. Firstly, the business needs to determine which organisational stakeholders will be given responsibility for identifying the business needs and requirements associated with the gap. Remember, these stakeholders are people who the business stakeholders have decided have a right to influence the system requirements. These major business stakeholders will then be tasked with identifying the constraints associated with the situation. Constraints can take many forms, but invariably exist, and they invariably limit the options open to the organisation in terms of the ultimate solution to their business needs. Stakeholders are then able to develop a more thorough understanding of the business needs that must be addressed by the system by exploring things like the mission, goals and objectives that the solution must address. Systems rarely sit in a perfectly isolated situation, so it's critical to understand where the system sits in relation to its environment and other external systems. This allows the stakeholders to understand and articulate the scope of the system. That is, what's considered to be in scope or part of the system and what's considered to be beyond the scope of the system. This activity also allows stakeholders to start to understand the potentially numerous interfaces with the external environment that need to exist. This information allows the stakeholders to look at feasible alternative solutions and extract more formal business requirements associated with their capability gap. The business requirements will be more formally stated than the needs. While the needs paint a picture of the problem and the desired solution, the business requirements are a further decomposition of the needs so that we can understand exactly what the business requires from the potential solution when it's deployed. When this work is complete, it's generally documented and reviewed by the business in order to endorse the work as representing what's required. This could be thought of as a formal approval process to allow the business needs and requirements to be used as the basis of the subsequent systems engineering effort. Let's take a look at these steps in more detail. The business needs to identify the people who will be able to execute the process described earlier. The people will be selected because they're either affected by the system in some way or can affect the system in some way. Selection of the correct stakeholders is an important first step because they will shape the system to come. Not everyone who's affected by or has an effect on the system will be considered stakeholders. This list would be far too big to be useful. The business needs to restrict the stakeholders to those who are considered to have the right to affect the system. Examples of typical stakeholders might include representatives from management who are directly impacted by the system or the need that the system is being designed to satisfy. Engineering and technical people who will be responsible for the design, development, testing and acceptance activities associated with the system may also be considered key stakeholders. Maintenance and logistics personnel who will be responsible for sustaining the system and ultimately disposing of the system will have a direct interest in forming the requirements for the system. In this way, the compelling metrics of life cycle cost can be taken into account. Also, the people who will use the system or benefit from the system will typically be represented in the key stakeholder group. These stakeholders will have plenty of work to do in the early stages of conceptual design. One of the things we need to understand as early as possible is the presence of constraints on the system. These constraints will be imposed on the system by virtue of the circumstances and will effectively limit the options associated with the system. If the system is not designed with these constraints in mind, it may fail to operate correctly when the constraints are imposed on it and therefore fail to deliver the results expected from it. Examples of constraints include business constraints like policies, procedures, standards, or existing relationships or contracts. Project constraints such as budget and schedule will impact on the options available as well. External constraints that are beyond the control of the organisation may also need to be identified and considered. Examples may include laws and regulations and the availability of skilled workforces. Finally, there may be some design-related constraints that need to be identified and considered. Examples might include technology stability and availability, design tool availability, and production and construction capabilities or limitations. Once we have the right stakeholders on board and we understand the constraints under which we are operating, the stakeholders are able to start working on developing an appreciation of the business needs that are driving the requirements for the system. A good starting point in any development of needs is to look at the mission of the system. This should be a concise statement, maybe only a sentence or two long, that captures the essence of the system. Once captured, the mission is generally explained and expanded on by a series of goal statements that relate to the mission. From these goals will come objectives that will help describe what the system needs to be able to achieve. In this way, we end up with a hierarchical structure where the mission spawns a number of goals, which in turn spawn a number of objectives. Another valuable exercise for the stakeholders to undertake is the development of short stories or descriptions of how the system will be used to solve the business need. These stories or descriptions are often called scenarios and allow stakeholders to paint a picture of the system and its use. Scenarios help develop an understanding of the importance of the operational and support environment, the various actors that will be involved with the system, the many external systems that may interact with the system, and the types of things that might go wrong when the system's being used. Scenarios may be developed using common tools like functional flow block diagrams, drawings, illustrations, simulations and models. Whichever is the most effective way of describing how the system will be used is fine. While stakeholders are busy developing scenarios that describe how the system will be used and supported, they should also be thinking about how the effectiveness of the system in meeting business needs is going to be confirmed. Convincing sets of stakeholders that their expectations of the systems have been satisfied is often referred to as validation. Determining the top-level validation criteria is therefore something that needs to be done whilst engaging with the relevant stakeholders. Knowing how a system is going to be validated by a group of stakeholders is something that will impact on the development of subsequent business stakeholder and system-level requirements via a hierarchy of measures of effectiveness, measures of performance, and related requirements verification statements. Finally, to complete the elicitation of business needs, stakeholders should define any important life cycle concepts associated with the system. Some of these concepts will be supported by the scenarios that have already been developed, but it's important for business stakeholders to explain their concepts, thoughts and expectations in relation to a number of things. For example, how will the system be operated? This is sometimes called an operational concept. How will the system be acquired? Sometimes called an acquisition concept, to cover things like the expected use of contractual models and so on. How the system will be deployed or transitioned from the acquisition phase to the utilisation phase. How the system will be supported during the utilisation phase, including ideas for contracted support versus in-house support and so on. And how the system will ultimately be disposed of, including expectations, constraints or requirements associated with the disposal. Whilst we're working on our basic business needs, we'll also be developing a much better understanding of the scope of our system. We're looking to understand the context of our system in terms of its environment and external systems, define the boundary of our system, that is, where our boundary begins and ends in terms of its environment and external systems, and therefore what external interfaces need to exist between our system and the external systems in our environment. The context of our system in terms of how it sits within its environment and external systems is often explained with a diagram called, not surprisingly, a context diagram. We've included a simple context diagram for a domestic burglar alarm system to give you a bit of an idea about what we're talking about. We can see here that if we're developing an alarm system for our house, it does not sit in isolation. It sits and operates within an existing and surprisingly complicated environment. Largely, it sits within our house, but in doing so, it interacts with the intruders as well. It will probably have to interact with our house's power system and our house's telephone network that connects our house to the outside world. In our diagram, we've shown this as a standard public switch telephone network, or PSTN. This might be mandated by a key stakeholder for some reason. Of course, if it's not mandated, we might be more general and leave the nature of that connection up to the designers in order to explore more modern options for connecting our alarm system to the monitoring agent. But in keeping with the idea that a picture paints 1,000 words, I'm sure you get the picture about context diagrams. The context diagram also helps clarify the boundary between our system and the external systems. For example, we are not responsible for providing power to our system. The power distribution subsystem in our house is responsible for that. This boundary will probably constrain our options, but it represents a boundary between our responsibilities and those of an external system, such as the power subsystem. Also shown on the context diagram are some external interfaces, listed in red, from E01 to E10. This allows us to start highlighting interfaces that need to exist across our system boundary in order for our system to work properly. Sometimes our system will be responsible for providing something to an external system. For example, E05 and E06 involve an interface between the alarm and the telephone network. The alarm system is responsible for achieving certain functions in order to interface with the PSTN so that we can alert the monitoring agent of an alarm operation. One interface may be to provide continuous status information to the agent, whilst another interface may be responsible for alerting the monitoring agent to the presence of an alarm event caused by an intruder. Sometimes our system will expect certain things from external systems via an interface. For example, E03. E03 is an interface where our system will expect to get single-phase 240 volt AC power at 50 Hz frequency over a standard power point. These interfaces are important to us because we need to make sure that the external system with whom we're interfacing does, in fact, support that interface that we're expecting.
If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.